we are discussing about later portions of relations and functions. We are very much aware of the concept relation. So let us take one more example for relations. This is a set A and another set B. There are two sets A and B. And a relation is taken from A to B. And it is named as capital R, relation from A to B. In A, the set A, there are several numbers, that is 1, 2, 3, 4, 5. In the set B, suppose the elements are A, B, C, D, E. And this 1 is connected to this A. That is 1A. 1A relation R. 1A, comma, and this 2 is connected to this E. 2E. Okay, 2E. These are our assumptions. And this 3 is connected to B. That is 3B. And 4 to C. 4C. And 5 again to A. 5 to A. 5A. This is a relation, and suppose there is any type of relationship between X and Y elements. This 1 and A are connected by any type of relation. We don't know about the relation. Okay. And 2E, 2 and E are connected by any relation, and so on, 3B, 4C and 5A. This is a relation. In this set, every element of A is connected with some of the elements of the set B. Here D is not connected with any of the elements of set A. These are the properties for this question. Okay, here the set A and B are connected or mapped by a relation R, and every element of the set A is connected with some of the elements of the set B. Right. So this is a relation. Let us take it as R1. Second relation, A, B. A relation R2 is taken from A to B. In A there are several elements. They are A, B, C, D. Here X, Y, Z. A is connected to X, B is connected to Y, C is connected to Z. So what about relation? R2 is equal to set AX, BY, CZ. Okay. Here every element of the set A is not connected with the elements of the set B. Here D has no connection with any of the elements of the set B. Clear? So now we are discussing about some types of particularity of relations. Here relation is started or mapped, or this R1 is taken from the set capital A to capital B. Here we can see every element of the set A is connected with the elements of set B, some of the elements of set B. But here every element of set A is not connected with the elements of or sum of the elements of the set B. To identify the elements of the set A or B, we can use the term image. So what is image here? A is the element of the set B. Here we say that this the whole B, the set whole B is what? Codomain, isn't it? Codomain. This is codomain. Then what is range? A, B, C, E. Set A, B, C, E. That is a range. What is domain? Set 1, 2, 3, 4, 5. So domain is a set of all elements of the first set from which arrow mark is started. Range is a set of all elements of the second set to which arrow mark is ending, isn't it? So here arrow mark is ending at A, B, C and E. So range of this R1 is what? Set A, comma B, comma C and E. Domain is what? Set 1, 2, 3, 4, 5. This whole set A for this question, because what arrow marks are started from each element of the first set, that is capital A. For this set, what is a codomain? The whole set B, as in this question, whole set B is a codomain. What is range? X, Y, Z, to which arrow mark is ending? X, Y, Z. So codomain and range are same for this question, isn't it? Codomain is the set B, range is also the whole set B, because what arrow mark is entered to each element of the set capital B. For this question, codomain and range are same set. Then what is domain here? Set A, comma B, comma C. The element D is missing because what? No arrow mark is started from the element D of the set capital A. So by comparing these two questions, we can see the difference with the arrow marks. In this question or in this relation, arrow mark is started from every element of the set capital A. Yes. By using this image, we can say that this A is the image of this one. 1A. A is the image of the element 1. E is the image of the element 2. B is the image of the element 3. C is the image of the element 4. And this A is the image of the element 5. Isn't it? A is the image of the element 1 and 5. What's the image of this one? That is A. What's the image of 2? E. Image of 3? B. Image of 4? C. Image of 5? A. Isn't it? That is image. Image of 1 is equal to A. Image of 2 equal to E. Image of 3 equal to B. Image of 4 equal to C. Image of 5 equal to A. Okay. For this question, image of A equal to X. X is the image, isn't it? X is the image of A. Image of A is equal to X. Image of B equal to Y. Image of C equal to Z. For D, there is no corresponding image in the set capital B. Okay, here every element of the set A has image in the set B. Here every element of the set A has not image in the set B because D has no image in the set B. How many images are there for the element 1? For this element 1, there is only one image, that is A. For this element, how many images for this element 2? Only one image, that is E. For this element 3, there is only one image, that is B. Okay. For this element 4, there is only one image, that is C. For this 5, there is only one image, that is A. Isn't it? A is the image for both 1 and 5. That is right. But this 1 has only one image, that is A. 5 has only one image, that is A. Or front. Suppose let us take the relationship as front. Front. The 1 and A are fronts. Okay. 1 or A is the front of 1 and this A is the front of 5. How many fronts are there for this one? That is A. Only one front. How many fronts are here for this 5? Only one front, that is 5. We don't know about 1 and 5 are fronts. We don't know. But 1 has only one front, that is A. 5 has only one front, that is A. A is a front for both 1 and 5. Okay. So the relation is taken as front, for example, isn't it? So this is the property of these two questions. For this question, every element of the set A has image in the set B. But here every element of the set A has not image in the set B because what? D is eliminated from this relationship or from this from the term image. Let's take one more example or more examples. See 3 and 3, 4, 5. How many images for this element A? 2 images. Images of A are 1 and 2. 1 is image of A, 2 is also an image of A. 3 is the image for B, C and D. Okay, B is connected with the element 3, C is also connected with 3 and D is also connected with 3. So 3, the number 3 is image for B, C and D. Okay, so every element of the set A has images in the set B. Clear? Every element or all elements of the set A have images in B. No elements of the set A are eliminated or isolated, isn't it? Because what? Arrow marks are drawn from each element of the set A. From here arrow mark, from B arrow mark, from C arrow mark, from D also arrow mark can be seen. For this question, every element of the set A has images because 1 has image, that is 5. 2 has image, that is 5. 3 has image, that is 5. For this question, every element of the set capital A has image. X has images, isn't it? Y has images. Z has images. So now we are focusing this type of property because you listen here with the property. See, every element of the set A has images in the set B which are unique. That is, every element of the set A has one and only one image in the set B. Every element of the set A must have one and only one image in the set B. If this property is satisfied by a relation, then we say that the particular relation is a function. 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 See the relation R1, is it a function? If R1 is a function, this R1 must be satisfied by the property what? Every element of the set A has one and only one image in the set B. 1 has image, that is A. 2 has image, that is E. 3 has image, that is B. 4 has image, that is C. 5 has image, that is A. Because every element of the set A has image. And this image is unique. One and only one image is drawn from each element of the set. How many images are here for the set 1? Only one image, that is A. How many images for the set for this element 2? Only one, that is E. How many for this 3? Only one, that is B. Only one is very important. How many images for this 4? Only one, that is C. How many for this 5? Only one, that is A. Isn't it? So every element of the set A has images, and these images are unique, or only one and only one images. Clear? Therefore, this R1 is a function. R1 is a function. So, examine whether this R2 is a function or not. First we check whether every element of the set A is connected with the elements of set B. We have to check it. Here D is not connected. So every element of the set capital A has not image in the set B. Therefore, this is not a function. Every element of the set A is not connected because D is not connected here. Therefore, R2 is not a function. Because arrow mark is not drawn from D. Therefore, this R2 is not a function. R1 is a function. R2 is not a function. See R3. Every element of the set capital A has images, isn't it? A has image 1 and 2. How many elements, how many images for this set, for this element A? 2 images. But we have one and only one image. Here A has 2 images. We know that every element of set A has images, but they are one and only one. One and only one property is not satisfied. Therefore, this R3 is not a function. It is a function. It is not a function. It is not a function. Clear? Here B has only one image, that is 3. C has only one image, that is 3. D has only one image, that is 3. But A has more than one images, 2 images. Therefore, this function relation is not a function. What about this one? Whether all elements connected with elements of the set B? Yes. Here arrow mark is drawn from each element of a set capital A. Isn't it? Image of images. How many images for this one? Only one. That is 5. How many images for this number 2? Only one. That is 5. How many images for this set is for this element 3? Only one. That is 5. Are all elements of the set A connected with the elements of the set B? Yes. Or because what? Arrow marks are drawn from each element. So every element of the set A has one and only one images in the set B. Therefore, this is a function. Then what about this one? Whether all elements of the set A connected with the elements of the set B? Yes, X, Y, Z. These X, Y, Z are connected by corresponding elements of the set A. But how many images for this element X? How many images? 3 images. 3 images. A, B, and C. Isn't it? So one and only one property is not satisfied here. Therefore, this is not a function. It is not a function. So what is function? a relation is said to be a function, or a relation from A to B. A relation from A to B is said to be a function if every element of the set A has one and only one images in the set B. By this property, this R1 is a function, isn't it? Every element has images and they are unique. Only one, only one, only one, only one, only one. Every element of this A is not connected because D has no images. Therefore, 2 is not a function. R2 is not a function. Third one, R3. Here R3 is not a function because what? A has more than one images. But all elements are connected, but A has more than one images. Therefore, R3 is not a function. Similarly, R4, 1, 2, 3, every element has images and one and only one property is satisfied. Therefore, R4 is a function. Whether R5 is a function or not, it is not a function because what? X has more than one images. Y has more than one images, isn't it? Every element is connected by the elements of the set B, but one and only one property is not seen for this question. What we discussed here, function. Function. What is function? A relation from A to B is said to be a function if every element of the set capital A has one and only one image in the set capital B. This is very important. A relation from the set capital A to the set capital B is said to be a function if every element of the set capital A has one and only one image, one and only one, very important, one and only one image in the set capital B. As it R1, first question, is R1 a function? Is R1 a function? Yes. Yes. Why R1 a function? Because what? Every element of the set capital A has one and only one image in the set B. Every element of capital A has one and only one image in capital B. Therefore, R1 is a function. Then what about R2? Is R2 a function? Is R2 a function? No. No. Why? D has no image. Every element of the set A has not image in the set B. Every element, ഇതിൽ D എന്ന് പറയുന്ന elementന് image ഇല്ല. Because R2 is not a function because what? D has no image in the set B. D has no image in the set B. Therefore, R2 is not a function. Similarly, is R3 a function? Is R3 a function? No. Why? Every element A is connected with the elements of the set B, that is okay, but one and only one property is not satisfied. Here, how many images for the set for this element A? Two images. So one and only one property is not satisfied. So this R3 is not a function because what? A has more than one images in B. A has more than one images in the set B. Therefore, that is one and only one and only one property is not satisfied, is not satisfied. Therefore, R3 is not a function because A has more than one images. That is, one and only one property is not satisfied. Similarly, is R4 a function? Is R4 a function? Yes, because every element of the set A has one and only one images in the set B. Image of 1 is 5, that is only one image is for 1, that is 5. Image of 2 is only 1, that is 5. Image of 3 is only 1, that is 5. Yes, it is a function. Yes. Why? Every element of capital A has one and only one and only one image in capital B. Every element of the set capital A has one and only one image in the set capital B. Is R5 a function? Is R5 a function? No. Why? Because X has more than one images, that is A, B and C. Y has more than one images. Isn't it? Every element is connected with the elements of the set B, but one and only one property of image is not satisfied. One and only one image property is not satisfied. Therefore, R5 is not a function. Clear? See this arrow diagram. A relation R is drawn or defined from the set A to the set B. A has three elements. They are 1, 2, 3, and B has 4, 5, 6, 7, 8 elements. 1, 2, 3, 4, 5 elements. Now I am drawing or I am defining a relation from A to B. 1, 4, whatever may be the relation. 2, 5, 3, 7. Clearly, R is a function. R is a function. Why? R is a function. Why? 1, 2, 3. All elements of the set A has images, and one and only one property of image is satisfied. That is, every element of the set capital A has one and only one image in the set capital B. Image of 1 is 4, which is unique, only one image, that is 4. Image of 2 is 5, only one image, that is 5. Image of 3 is 7, only one, isn't it? So all elements of the set A have images and which are unique in the set B. Therefore, R is a function. Therefore, we can change this R as F function. Now it is a function. Here R is replaced by F function, isn't it? Then 4 is the image of this one under the function F. 4 is the image. 4 is the image of the element 1. 4 is the image of the element 1 under the function F. 4 is the image of the element 1 under F, and it is denoted by F of 1 equal to 4. F of 1 equal to 4. So what is F of 1 equal to 4? Image of 1 under the function F is 4. F of 1 equal to 4. Similarly, F of 2 equal to 5. F of 3 equal to 7. Okay, then what is range or domain? Domain of F. What is domain of F? Set 1, 2, 3, isn't it? Set 1, 2, 3. That is always first set A, isn't it? Domain of a function is a starting set A. That is definitely true because what? Every element of the set A has images in the set B. So every element of the set capital A means what? The entire set capital A, the whole set capital A. So for a function, domain will also be the first set capital A. Domain is equal to A. Then what is range? Range of F. Range of F is what? Set 4, 5, 7. Set 4, 5, 7. 4, 5, 7. Then what is codomain? Codomain of F is equal to, codomain means always the set capital B, the big set capital B. That is codomain. So now we are dealing with the notation F of 1. F of 1 is equal to 4. Generally F of, this is first element, first set, and it is a second set. When we are taking graphical representation, first one is used for x-axis, second one for y-axis. So first element is small x, etc. Second element small y, etc. Okay. So this is for x-axis, this is for y-axis. Then f of x equal to y. F of x equal to y. Then comma where x belongs to x-axis, y belongs to y-axis, isn't it? So another name of y is what? F of x for a function f. F of x equal to y. So by saying f of x equal to y, which means what? Image of x under the function f is y. See, where small y belongs to capital Y. Small y can be seen along capital Y and small x can be seen along capital X. F of x equal to y. This is general notation for graphical representation of a function f. F of x equal to y. This table form or tabular form. tabular form or table form. Here x and y. A relation or relation R1, R1, xy, 1a, 2b, 3c, 4d, 5e, 6f is R1 a function? Is R1 a function? 1, 2, 3, 4, 5, 6. All these elements are connected with A, B, C, D, any of A, B, C, D, E, F. Okay. Then what is the image of 1? That is A. Image of 2, B. Image of 3, C. Image of 4, D. Image of 5, E. Image of 6, F. How many images are here for this element 1? Only one image, that is A. So one and only one property is satisfied here. 2, image of 2 is B, which is unique, that is B. Image of 3 is C, which is unique, that is 1. Only one image, that is C. And same property can be seen everywhere in this table. Therefore, R1 is a function. Yes. Why? Every element of every x element, every x element has one and only one y element. One and only one image. One and only one image. Therefore, it is a function. Clear? Then, what about second one? Is R2 a function? Is R2 a function? A, B, C, D, E. What is the image of A? That is 5. How many images for A? Only one, that is 5. Okay. How many images for B? Only one, that is 5. How many images for C? Only one, that is 5. Okay, okay. Therefore, what? Therefore, it is also a function. Yes, same property. Every x element has one and only one image. Then, what about third one? This is R2. Then, what about R3? Is R3 a function? Is R3 a function? 1, 2, 1, 2, 1, 2. Here, elements of the set are repeated. Repetition is not allowed here. But here, these are here 1 and A are connected. Image of 1 is A here. Image of 1 is E here. So, which means what? 1 has more than one images. Isn't it? If 1A, it is also 1A, then what? Elements of the set are repeated and hence one can be eliminated. One element, repeated element can be eliminated. But here, no repetition here. These are points 1A, it is 1E. Image of 1 is here A, image of 1 is here E, which means what? The element 1 has more than one images. So, one and only one property of image is not satisfied. Therefore, R3 is not a function. Similarly, image of B, image of 2 is what? B. Image of 2 is what? Here, D. So, the number 2 has more than one images. Here, a number of images for 1 is what? A, C, E. More than one images. So, one and only one property is not satisfied. Similarly, for the element 2, there are two different images, B and E. Therefore, it is not a function. Now, why 1 and only one image property is not satisfied. Therefore, R3 is not a function. Clear? See these graphs. There are two relations R1 and R2. It's English alphabet capital S. It is English alphabet capital B. Clear. Anyway, these two are graphs. Therefore, we say that graphical representations of relations. We are expressing this alphabet by in terms of or by using graphs, isn't it? So they are what? Graphical representations. Graphical representation. Graphical representation. Is R1 a function? So when we are saying about graph, x and y value are to be compared, isn't it? For one x value, there should have only one y value. That is one and only one property is to be satisfied. Here we are taking the domain as here up to here, because this graph or this capital S takes x values up to here, isn't it? So x space on x-axis, this much space on x-axis is needed to draw this one, isn't it? So remaining portions are to be uh, nullified, or this can be eliminated. Okay, only this region is to be taken. This is its domain. If I am taking an x value here, suppose it is an x value, x. What about its corresponding y value? Here, this is y. Okay, y. So here x image of x is y. Image of x is y. Can you see any another image for this x? Yes. Another y value here. Another y. Let it be y1. It is y2. Then image of x is y2 also. It is y1. Then can you see another image? It is y3. Image of x is y3. How many images are here for one x? For this x, there are 3 images, y1, y2, y3. Therefore, R1 is not a function. Here, R1 is not a function because one and only one property, one and only one image, one and only one image property is not satisfied. Therefore, it is not a function. This is not a function. Then, is R2 a function? Is R2 a function? In the same way, we can take domain or x values up to here, isn't it? Domain means what? To draw this B, how many or how much spaces are needed on x-axis? For first set, that is first set is here x-axis. X, it is capital Y. X, it is capital Y. So here a relation is defined from capital X to capital Y. So this is domain. When we are taking a point which is x here, how many x y values for this x? Image of x is y here. So image of x is y. Can you see another image? Yes. It is another image. It will be y2. It is y1. Image of x is y2. Similarly, here y3 image of x is y3, again y4 image of x is y4. This means what? For one x there will be different images, more than one images on capital Y, isn't it? Therefore it is also not a function. No, because what? One and only one image property is not satisfied. Clear? So this is all about the graphical representation of a function or relation. Okay. Here relations are expressed in a roster form. Are they a function? First one, is R1 a function? Image of 2 is 1. No other elements are here as image for this 2. Only image for 2 is 1. Here image of 5 1, 8 1, 11 1, 14 1, 17 1. So every element has one and only one images, isn't it? Therefore R1 is a function. Because what? Because every element has one and only one image. Okay. Then what about second one? 2 1, 4 2, 6 3, 8 4, 10 5, 12 6, 14 7. Similarly, R2 is also a function. Image of 2 is 1, 4 is 2, 6 is 3. So R2 is also a function. R2 is a function. Because what? Same reason. Because every element has one and only one image. Third one, R3. Is R3 a function? Image of 1 is 3. Image of 1 is 5. So 1 has more than one images, that is 3 and 5. Therefore, it is not a function. R3 is not a function. Because what? Because one and only one property is not satisfied. That is what? Image of 1 is image or image of 1. Images of 1 are 3 and 5. 3 and 5. Therefore, R3 is not a function. Say question here, find the domain and range of the real functions f of x equal to minus mod x, modulus x. F of x equal to root of 9 minus x square. Your question is describing about real function. What is real function? There are two types of function which we are discussing here. First one, real valued function. Real valued function. Real valued function means in a function, if its range is a set of real numbers or the subset of real numbers, then the function is called as real valued function. What is that? In a function, if its range is the set of real numbers, or the subset of real numbers. In a function, if its range is a set of real numbers or the subset of real numbers, then it is said to be real valued function. Real valued function. For example, a, b. A function is taken from a to b. Here 1, 2, 3, 4, 5, 6. Or it is some x, y, z. We don't know about the nature of x, y, z. And b is very clear. 4, 5, 6. These 4, 5, 6 are real numbers, isn't it? So set 4, 5, 6 is the subset of real numbers. Here a function is defined from x to 4, y to 5, z to 6, isn't it? Is it a function? Yes, because what one and only one property is satisfied. Every element of set capital A has one and only one image in the set capital B. Therefore, it is a function clearly. Okay. Then here range is what? Range is equal to set 4, 5, 6. Actually, this is a subset of real number. For the subset of real number, range is a subset of real number. Range is a set of real number or subset of real number. Here it is a subset of real number. A subset of real number, isn't it? Therefore, f is what? A real valued function. Therefore, f is a real valued function. That is real valued function. Here x, y, z may be real numbers or any other numbers. What are real numbers? Real numbers are the numbers which you have learned till now, isn't it? നിങ്ങൾ ഇപ്പോൾ ഈ മൊമെന്റ് വരെ പഠിച്ചിരിക്കുന്ന എല്ലാ നമ്പറിനും നമ്മൾ എന്താ പറയുക? റിയൽ നമ്പർ എന്നാണ് പറയുക. 0 is a real number. All negative numbers are real numbers. Positive numbers are real number. Radicals means root of 2, root of 3, root of 4. They are also real numbers, isn't it? Then what about root of minus 9? Or root of 9 is what? 3. Root of 9 means 3. Why we say that root of 9 is equal to 3? Which means what? 3 into 3 is equal to 9. Then what about root of minus 9? Root of minus 9, is it minus 3? If it is minus 3, then minus 3 into minus 3 is equal to minus 9. Is it correct? Minus 3 into minus 3 means what? Plus 10. Two negatives will become positive. So minus 3 into minus 3 is equal to plus 9. Therefore, root of minus 3 is not equal to minus 3. Root of minus 9 is not equal to minus 3. Such numbers are called as non-real numbers. Non-real numbers, and it is called as complex number. That will be learned later. Okay. So the square root of negative numbers are what? Non-real numbers. So x may either be real numbers or either or complex numbers. So anyway, a nature of x is not defined here, and we are now focusing only on the range set, isn't it? If range set is a real number set or a subset of real number set, then this function is called as what? Real valued function. Okay. Similarly, another one is what? Real function. Real function. What is a real function? See, or in a function, if its domain also a set of real numbers or the subset of real numbers, then the function is said to be real function. Real function. So here, if the range is the set of real numbers or the subset of real numbers, that is called as what? Real valued function. And here, if range and domain are also a set of real numbers or subset of real numbers, that is what? Real function. It is different only for range. It is different for both domain and range. So in a function, if its domain also, domain 2 means what? Both domain and range. Domain also a set of real numbers or the subset of real numbers, then the function is said to be real function. Okay, so here an example, a b, a function is taken here, 1 2 or root of 5, okay, 3 root of 7 4, 1 3 2 root of 7 root of 5 root of 4. Here 3 root 7 root 4. Range, what is range here? Range means set 3 root 7 4. It is a subset of, it is a subset of real number set, isn't it? Then what about domain? Domain is equal to set 1 2 root 5 is also a subset of real number, is also a subset of real number. Therefore, this is what? A real function. It is a real function, isn't it? Real function. It is a real function. So the only difference in real function and a real valued function is what? A real valued function is focusing only on the range. If range is either a set of real numbers or a subset of real numbers, then it is called as what? Real valued function. But for a real function, if it's both domain and range are set of real numbers or the subset of real numbers, then it is what? Real function. Okay, so that term is used here, real function. So real function എന്ന് പറഞ്ഞാൽ നമ്മൾ ഇത്ര നോക്കാനുള്ളൂ, ആ ഫംഗ്ഷന്റെ ഡൊമൈനും റേഞ്ചും ഒന്നുകിൽ റിയൽ നമ്പർ സെറ്റ് ആവണം അല്ലെങ്കിൽ അതിൻ്റെ സബ്സെറ്റ് ആവണം. ഇനി റിയൽ വാല്യൂഡ് എന്ന് പറഞ്ഞിട്ടുള്ളെങ്കിലോ ഡൊമൈനെ പറ്റി നമ്മൾ ബോധറാവണ്ട, ഇതിനെ പറ്റി മാത്രം നോക്കിയാൽ മതി, റേഞ്ചിനെ പറ്റി മാത്രം നോക്കിയാൽ മതി. റേഞ്ച് മസ്റ്റ് ബി എ റിയൽ നമ്പർ സെറ്റ് ഓർ ഇറ്റ്സ് സബ്സെറ്റ്. ഓക്കെ, സോ here question is saying about real function, so we have to examine both the domain and range, isn't it? So let us take this question. Say question, find the domain and range of the real functions. F of x is equal to minus modulus x. First one, minus modulus x. What is mod x? What is mod 3? That is 3, taking its content, its value. Mod minus 3 is also 3 because we are taking only positive values. Modulus means to take positive value only. What is mod 1.5? That is 1.5 itself. Mod minus 1.5, 1.5, isn't it? So we are taking only positive values. If we are taking the function modulus x, modulus x. Here we have to find domain and range. This function is a real function because we are taking only real number values, okay, for both domain and ranges. Which are the possible values to be put for x? Can you here f of x is equal to minus mod x. Another name of f of x is what? Y. Here y is equal to minus mod x. F of x means y. When x is equal to 0, is x equal to 0 a real number? Yes, a real number. Real number. What will be y? Y is equal to minus mod 0. So we are putting x as 0. So minus mod 0, which is what? Mod 0 is 0. Minus mod 0 is 0. What is minus 0? That is 0. Okay. So we got a y value. No problem. Similarly, when x is equal to a positive number, say 1, then what will be y? Y is equal to minus mod 1. That is minus. Modulus of 1 is 1 itself. Okay. Is also a real number. 0 is a real number. Real number. Minus 1 is a real number. No problem. Because question is saying about real function. So we got a real value also. When x is equal to negative number, say minus 1, then what is y? Y is equal to minus mod minus 1. Minus mod minus 1. We are putting negative 1 for x. That is equal to minus. What is modulus of minus 1? Modulus of minus 1 is equal to 1. Minus 1 is also a real number. Real number. No problem. Okay. So uh, which values can be assigned for x? You can take any values from real numbers. Okay, minus 1, minus 2, minus 3, minus 4, all negative values can be taken for x. Similarly, 0 can be taken. It is very clear from here. Similarly, all positive value can be taken as x values. No problem. 1, 2, 3, 4, isn't it? For every real numbers, this function y is equal to minus mod x will be satisfied, isn't it? So what will be domain? Therefore, domain of f means for all real numbers. All real numbers. This means what? All real numbers can be assigned as the x values, isn't it? This means what? Real numbers. Real number sets. To more clear, we can take as this one. R. Set of real numbers. All real numbers. Or set of all real numbers. Set of all real numbers is described as what? Script R. So that is the domain of this function. Domain means set of all real numbers. Then what about range? Range of f is equal to what? When you put x equal to 0, you got 0. When you put x is equal to positive number, you got negative. When you put x equal to negative number, you also got negative. So range means y values. Y values means range. So range is the set of all real numbers other than positive numbers. You will never get a positive number here. When you substitute x is equal to 2, you will get minus 2 here. It's negative. When x equal to 3, minus 3, isn't it? X equal to 4, minus 4. Similarly, when x is equal to minus 1, answer is minus 1. X equal to minus 2, answer is minus 1. X equal to minus 3, answer is minus 1. Minus 3. This means what? No positive answer is found out. പോസിറ്റീവ് ആൻസർ കിട്ടുകയില്ല. നിങ്ങൾ ഏത് വാല്യൂ കൊടുത്താലും ആൻസർ ആൻസർ കിട്ടുന്നത് എന്തായിരിക്കും? ഐദർ 0 or negative numbers. So range is a set of all real numbers other than positive real numbers, isn't it? Range means what? Set of all real numbers other than positive real numbers, isn't it? This can be written as what? Up to from minus infinity to 0. 0 is included. 0 is included, isn't it? Positive, all positive numbers are excluded. Positive numbers are not available here, isn't it? Minus infinity. Since minus infinity is unknown, we are taking this type of bracket, open bracket. So minus infinity to 0 is a range of f. Once again, here f of x is equal to modulus of x. Modulus means taking only positive values, minus of modulus x. Modulus of 3 is 3, modulus of minus, these are for examples. F of x equal to minus mod x. Another name of f of x is equal to y, image of x under the function f. Y is equal to minus mod x. For example, when you take x equal to 0, then minus mod 0. Mod 0 is 0, then minus 0 is 0. 0 is also a real number. Y, this y is corresponding to range, x is corresponding to domain. Okay. When x is equal to positive number, for example, you are taking positive number as 1, then y is equal to minus of mod 1. Minus of what is mod 1? 1. So you got minus 1, which is also a real number, and this minus 1 will go for range. And when this x approaches to the domain set. When x is equal to negative number, take negative number as minus 1, y is equal to minus mod minus 1, mod minus 1 is 1, and minus is outside, so answer is minus 1 is also a real number. So for all values of real numbers x, you will get only negative numbers and 0 as the elements in the range. Therefore, domain is a set of all real numbers that is script R, whereas range of the function f is a set of all real numbers except positive numbers. A set of all real numbers except positive numbers means what? Up to 0. Minus 100, minus 99, etc., etc., minus 4, minus 3, minus 2, minus 1, 0, up to 0. Isn't it? So no positive numbers are found out here. So that is all about this question. Okay. The second question. F of x is equal to root of 9 minus x square. So you have to check both x and y values for this function. And the answer must be only real numbers. Real numbers means you know real numbers. What are non-real numbers? Radical part containing negative. Root of minus 3, root of minus 4, root of minus 5. So inside the root symbol, if there is negative presence, the presence of negative is found out, then it is part non-real numbers. All other numbers are real numbers. F of x equal root of 9 minus x square. Put, for example, x is equal to minus 3. It is a real number. X is equal to minus 3. It is a real number. Then what is y? Y is equal to root of 9 minus x minus 3 square. That is equal to root of 9 minus 3 square means 9. Both 3 square, what is 3 square? 9. Minus 3 square is also 9. Then what is 9 minus 9? 0. Root of 0 is 0, a real number. 0 is a real number. Then put x is equal to minus 2. It is also a real number. Then y is equal to root of 9 minus 2 square is equal to root of 9 minus 2 square means 4. That is equal to root of 5. Root of 5 is a real number. Root of 5 is 2 point something. You can find the value by using calculator. It's also a real number. Here negative is not included. If negative is included, it will not be a real number. If there is a negative root of negative 5, that will not be a real number. But our question is aimed only for real valued function. So here there is no negative, therefore no problem. Similarly, put x is equal to minus 1. Minus 1 is a real number. Then y is equal to root of 9 minus minus 1 all square. That is root of 9 minus negative 1 square means 1. That is root of 8 is also a real number. And root of 8, its value can also be calculated by using a calculator. Then put x is equal to 0. 0 is also a real number. Then y is equal to root of 9 minus 0 square. That is equal to root of 9 is equal to 3. 3 is also a real number. Then you take x is equal to 1. X is equal to 1. Then y is equal to x is equal to 1. Then y is equal to root of 9 minus 1 square. That is root of 9 minus 1 root of 8 is a real number, belongs to a real number. Okay, real number. Put x is equal to 2, y is equal to root of 9 minus 2 square, root of 9 minus 4 is root of 5 is also a real number, belongs to R. Put x is equal to 3, y is equal to root of 9 minus 3 square, root of 9 minus 9, root of 0 is equal to 0 is also a real number. Then what happens? Now I am taking x values from minus 3 to plus 3, minus 3, minus 2, minus 1. When we draw a number line here, 0, 1, 2, 3, minus 1, minus 2, minus 3. I am using real numbers from minus 3 to plus 3. Minus 3, minus 2, minus 1, 0, 1, 2, 3, isn't it? So several numbers are between minus 3 and minus 2, and these all are included, and for our convenience I am taking only numbers from minus 3 to plus 3. Then what happens if I am taking minus 4? What happens if we put x is equal to minus 4? What happens? Y is equal to root of 9 minus minus 4 square, isn't it? 9 minus minus 4 square. That is root of 9 minus minus 4 square means 16. Root of, what's 9 minus 16? Minus 7. Here root symbol containing negatives. So root of negative 7 is not a real number. Not a real number. So if we take x equal to minus 4, the function will not be a real function. Similarly, what happened if we put x is equal to 4, here minus 4, here 4. When x is equal to 4, then y is equal to root of 9 minus 4 square, that is root of 9 minus 16. That is again root of minus 7 is not a real number. Then the function will not be a real function. So we can take values only from minus 3 to plus 3. That is why I am starting with minus 3 and ending at plus 3, isn't it? So only possible values for x are from minus 3 to plus 3. Therefore what? The domain, x means domain values. Therefore domain of this function, domain of f is equal to the number starting from minus 3 and ending at plus 3. This is the domain. Okay, this is domain. Then what are the answer obtained? When x is equal to minus 3, we got answer as 0. When x is equal to plus 3, answer is also 3. So which are the corresponding answers are in between 0 and which number? 3, isn't it? When x is equal to maximum, minimum number is 0 and maximum number is 3. So range of f y values is equal to 0, 3. 0, 3. Both 0 and 3 are included, isn't it? Domain values are in between -3 and +3, including -3 and +3. When we substitute -3, we will get answer as 0, +3 answer as 0. So minimum value of range set, minimum element of range in range set is 0 and maximum element can be seen as 3. So these two numbers are included. Therefore, we are taking closure interval symbol. Okay, so domain is -3 to 3, range is 0 to 3. Find the domain and the range of the function. This is also a real function. F of x equal to 2 plus root of x minus 1. Here a function f of x is equal to 2 plus root of x minus 1. Can you put x is equal to 0 here? When x is equal to 0, 2 plus root of 0 minus 1. What is 0 minus 1? Minus 1, root of minus 1. So root symbol containing -1, which is not real number. So 0 is not possible here. What happens when x is equal to 1? When x is equal to 1, then y means f of x. 2 plus root of 1 minus 1, that is 2 plus root of 1 minus 1, 0. 2 plus 0, that is 2. No problem, it's a real number. Okay, so x is equal to 1 is possible, but x is equal to 0. When draw a number line, 0, 1, 2, 3, minus 1, minus 2. So 0 is not possible, 1 is possible. 1 is possible. Then is 2 possible? Root of 2 minus 1. 2 minus 1 is 1. Root of 1 is equal to 1. Okay, no problem. 2 is also possible. 3. Root of 3 minus 1. 3 minus 1. 2. Root of 2. That is 1.414. It can be calculated by using calculator. No problem. 3. Root of 3. For what is 4? Root of 4. Root of x equal to 4. Root of 4 minus 1. That's root of 3. 1.73 is also possible. So x values are possible. X values are from 1 to infinity, isn't it? Possible x values are, this means possible x values are from 1 to infinity. Therefore domain of f is equal to from 1 to infinity. Okay, infinity is unknown, therefore this type of bracket is used always. 1 to infinity. So x values, we can substitute x values from 1, 2, 3, 4, 5, etc. up to infinity. Then we got y values as real numbers. When we put x is equal to 1, we got answer 2. Okay, so for this 5 means range set. So range set is starting with the number 2. Then what happens when we substitute x is equal to 2, root of 2 minus 1, that is root of 1, 2 plus 1, 3, isn't it? Okay. When x is equal to 4 or x is equal to t, when x is equal to 2, y is equal to what? 2 plus root of 2 minus 1, that is 2 plus root of 2 minus 1, 1, 2 plus root of 1, 1, that is 3 is also real. So first answer is 2, second answer is 3. Then what about when x is equal to 3, y is equal to 2 plus root of 3 minus 1, that is 2 plus root of 3 minus 1, 2. That is 2 plus root of 2, 1.414. is also real. When x is equal to 4, we got 2 plus root of 4 minus 1, 3. When x is equal to 5, similarly, when x is equal to 5, y is equal to 2 plus root of 5 minus 1, that is 2 plus root of 4, that is 2 plus, what is root of 4? 2. 2 plus 2, 4. So, y values are approaching from 2 to infinity, isn't it? 2 to infinity. Then, range is what? Range of f is equal to, starting point is 2, and this will end at infinity. Okay. First answer is 2, second answer 3, third answer 3 point something, fourth answer and so on, fifth answer 4, and this will approach up to infinity. Since infinity is unknown, we can use this type of bracket. So range of f is equal to 2 comma f, 2 comma infinity. Answer this question. Find the domain of the function. Here only domain is asked to find out, because finding range is a complex one, a complexity type. So that is why here question is asked only for finding domain of the function. So it is very simple. Here f of x is expressed as a quotient form or a by b, like division form, division p by q form, rational form, rational form. Rational form. Rational form is what? P by Q. Numerator and denominator. What is the feature or a main property of a function of the form P by Q? Here Q never 0. That is, we know that 1 by 2, its answer is 0.5. Okay, clear. 1 by 4, this is 0.25. Okay. What about 1 by 0? 1 by 0. Do you know 1 by 0? Just division by 0 is not possible. Not possible. Okay. You take a calculator and you find its value 1 by 0. Then calculator show an error symbol, E symbol in the right or left corner, isn't it? So division by 0 is not possible and no one found out its value. So 1 by 0 is not possible. Similarly, 2 by 0 is not possible. 3 by 0 is not possible. 0 by 0 is not possible. 0 by 5, it is possible. Answer is 0. This is possible. What I said? Division by 0 is impossible. But 0 by 4 is possible. Its answer is 0. What is 0 by 10? Is 0. That is also possible. But division by 0 is impossible. Okay. Then here, this function is expressed as rational form, that is p by q form. Here p is the numerator, q is the denominator, p by q. So this x square minus 5x plus 4 never 0. Since f of x is expressed as p by q form, comma, where p ever q not equal to 0, x square minus 5x plus 4 not equal to 0. That is very important. Whatever may be the numerator, you leave it numerator x square plus 3x plus 5, whatever may be its value, you have to focus only on the denominator. Why? Since function is expressed in p by q form, since it is in p by q form or rational form, q must not be 0. Then x square minus 5x plus 4 equal to 0. Then f of x is equal to x square plus 3x plus 5 divided by How can you factorize this x square minus 5x plus 4 as an 8th standard? First you substitute here x because x into x square. So we are going to factorize x square minus 5x plus 4. Then next term, here minus 5, here plus 4. So you have to think two numbers so that their sum will be minus 5 and a product will be plus 4. Which are the two numbers? Sum will be minus 5. Minus 4 and minus 1. When you assign minus 4 and minus 1, what is minus 4 plus minus 1? Minus 4 plus minus 1 is equal to minus 5. Okay. Similarly, minus 4 into minus 1. 4 into 1, 4 plus minus into minus plus. Right. So x square minus 5x plus 4 can be factorized as x minus 4 into x minus 1. You can clear your doubt. X minus 4 into x minus 1. X minus 4 into x minus 1. You multiply minus 1 into minus 4 plus 4. Minus 1 into x minus x. X into minus 4 minus 4x. X into x square. So plus 4 minus 4x minus 1x minus 5x. Here x square. X square minus 5x plus 4. That's why we are factorizing x square minus 5x plus 4 as x minus 4 into x minus 1. Its simple way is to identify two numbers whose sum will be minus 5, middle term minus 5, and their product will be plus 4. Then which are the numbers? Minus 4 and minus 1. Minus 4 and minus 1. Okay. Then here, for what values of x this function f of x is not defined one or not a possible one? What happens when x is equal to 4? You leave it numerator നോക്കണ്ട. You just look at denominator only. What happens when x is equal to 4? When x is equal to 4, 4 minus 4, that is 0. 0 into, what about maybe this one? 0 into this one means 0. So denominator will be 0. So you can't substitute x as minus 4. Similarly, what about x equal to 1? 1 minus 1, 0. So 0 into this number, 0. Then denominator will be 0. Then this type of question is here, which is not possible. So for this function, this f of x will be invalid or not defined when we put x is equal to 4 and x is equal to 1. You can't put x is equal to 4 and x equal to 1, isn't it? When you substitute x is equal to 4 and x is equal to 1, this function will be invalid. Value undavilla, invalid or not possible form or not defined form. So all other numbers other than this 4 and 1 can be substituted. You can substitute x equal to 0. 0 minus 4, that is minus 4. 0 minus 1, that is minus 1. So minus 4 into minus 1, that is plus 4, no problem. But you can't substitute x equal to 4 and x equal to 1. All other real numbers are possible to identify its value, isn't it? So what about domain? Domain is equal to set of all real numbers other than this 1 and 4. From the set of real numbers, you can't substitute x as 1 and 4. All other numbers can be substituted here to find the value of f of x. Therefore, domain is equal to script r difference, not negative minus. In set we had learned the symbol as difference. Script r difference set 1, 4. Okay. Consider the function f of x is equal to root of x minus 2. And another function g of x equal to x plus 1 divided by x square minus 2x plus 1. And you have to find these 4 questions. First one, find the domain of f. This direct question. Domain of f, t of f root of x minus 2. So only focus on the radical part. Inside the radical part, there will not be any negatives. When x is equal to 2, root of 2 minus 2. When x is equal to 2, what is f of x? Root of 2 minus 2 is root of 0 is equal to 0. No problem. It's a real number. When x is equal to suppose x is equal to 3, then f of x is equal to root of 3 minus 2, that is root of 1 is equal to 1 is also real. When x is equal to 4, f of x is equal to root of 4 minus 2, root of 2 is also real. Its value will be obtained by using calculator 1.414, etc. So anyway, when x is equal to 1, what happens when x is equal to 1? When x is equal to 1, f of x is equal to root of 1 minus 2, root of 1 minus 2 minus 1 is not a real. It is not a real because what? A negative number is included in the radical part. That is a non-real number. So x is equal to 1. This is impossible. That is x is equal to 1 is not possible. So which are the values to be assigned for x? Values from 2 onwards. 2, 3, 4, etc. From 2 onwards. So domain of f is equal to what? 2 is the first number, then up to infinity. To infinity is the domain of the function. Then second one, find the domain of g. What is g here? G of x is equal to x plus 1 divided by x square minus 2x plus 1. As in the previous case, we can factorize this one. X plus 1 divided by, you have to think 2 numbers so that their sum will be minus 2 and the product will be plus 1. X, which are the 2 numbers? Minus 1 and minus 1. Minus 1 plus minus 1, that is minus 2. Minus 1 into minus 1, that is 1. So x minus 1 and x minus 1. What happens when x is equal to 1? When x is equal to 1, denominator will become 0. The denominator is 0. When x is equal to 1, denominator is 0, which is impossible, impossible. So here same, x is equal to 1, isn't it? So what will be domain? Domain of f is equal to a set of all real numbers other than set 1, only 1. They are same. Script r minus set 1, or a set of real numbers minus set 1. That is domain of f. Then third one, f plus g of x. F plus g of x means, what is its meaning? F plus g of x means f of x plus g of x. What is f of x? Root of x minus 2 plus, what is g of x? X plus 1 divided by x square minus 2x plus 1. That is his answer. Very simple answer. Then fourth one, f plus f into g. F into g of x means what? F of x into g of x. What is f of x? Root of x minus 2 into g of x, x plus 1 divided by x square minus 2x plus 1. That is all about its answer. Here a question, if f of x equal to x square, find the value of f of 2 minus f of 1 divided by f of 2 plus f of 1. Very simple question. Here f of x is given as what? X square. Then what is f of 2? F of x is x square. F of k is k square. F of a is a square. So f of 2 is 2 square. What is 2 square? 2 into 2, that is 4. So f of 2 is 4. Similarly, what is f of 1? F of x is x square. So f of 1 is 1 square. What is 1 square? 1 into 1. 1 into 1 is 1. So that is all about this fraction, isn't it? So f of 2 minus f of 1 divided by f of 2 plus f of 1 is equal to, what is f of 2? F of 2 is 4 minus, what is f of 1? 1 divided by f of 2, 4 plus f of 1, 1. 4 minus 1, 3. 4 plus 1, 5. So its value is 3 by 5. Very simple question. One more question. Find the domain of the function f of x equal to x square plus 2x plus 1 divided by x square minus 8x plus 12. Only domain is asked to find out. So for that, since this question is expressed in rational form, that is P by Q form, its property is what? Q never 0. So firstly, we are going to factorize this one as x square plus 2x plus 1 divided by x. Okay, then you have to think two numbers so that their sum will be minus 8 and the product will be 12. Which are the numbers? Yes, minus 6 and minus 2. Minus 6 plus minus 2 is minus 8. Okay. Minus 6 into minus 2 is equal to plus 12. Two negatives will become positive. So minus 6 into minus 2 is equal to plus 12. Right. Then what happens when x is equal to 6? X is equal to 6 means not possible. X equal to 6, 6 minus 6, 0. Since denominator is 0, the value is not possible. Put x is equal to is again not possible. When x is equal to 2 minus 2, 0, denominator will never become 0. So 6 and 2 are not impossible values to be substituted for f of x. Then what will be domain of f? Therefore, domain of f is equal to set of real numbers minus 2 comma 6, not minus, difference 2 6. So this is the domain of the function f of x. So that is all about this chapter. Then now we are at almost end of this chapter. Then we have to draw several graphs of certain functions. So that will be discussed in next class. So now we are going to stop this class here. And I think you are well aware of the function and different operations on the function. Lastly, we are at the value of the function and domain and range of the function. So now I am stopping this class here. We will meet again on next class. Okay, thank you.